Welcome to Spaceverse, your portal to cosmic adventures. Once more, the James Webb Telescope has provided the picture that has been anticipated for a very long time. The photos that were released by NASA have now revealed strange planets that run counter to our long-held assumptions about the probability of life existing in the universe. In the Kuiper Belt, a dwarf planet with the designation 2007 OR10 is revolving around the Sun. It has been observed to display some indicators of life that cannot be explained by any other explanation. Is it possible that life could be discovered on this planet for the very first time in all of space and time? In the realm of science, 2007 OR10 is a masterpiece. Despite the fact that it is located so far away from Earth in our solar system, this enormous new planet is beyond anything that scientists could have envisioned. Since 2007, astronomers have been interested in this dwarf planet because of the observations that have been made of it. It is one of the largest dwarf planets in our solar system, with a diameter of roughly 1,535 kilometers, and 2007 OR10 provides evidence of a surface abundant in complex organic compounds. These astronomers were able to locate this planet with the assistance of the Samuel Oskin telescope that is located at the Palomar Observatory. The fact that it is located in the Kuiper Belt and has a slow rotation of approximately 45 hours contributes to the mystique that surrounds it. It is one of the most enigmatic things that we are aware of. As part of their efforts to reach the ocean depths, scientists are currently making preparations to launch their brand new wonder weapon to the surface of the Earth. This sophisticated piece of technology is poised to revolutionize our understanding of deep-sea environments, providing unprecedented insights into the mysteries that lie beneath the waves. Meanwhile, in the realm of space exploration, the James Webb Telescope is essentially destined to investigate distant celestial objects in exquisite detail. Provided that it is located in a very remote location, the telescope can focus on a planet that is exceedingly dark, such as 2007 OR10. This distant world, shrouded in darkness, holds secrets that the James Webb Telescope is uniquely equipped to uncover, bringing the far reaches of our solar system into clearer view than ever before. Through these dual endeavors, scientists are pushing the boundaries of exploration both beneath our oceans and beyond our planet. Each and every detail is documented by James Webb. Who could have conceived of the possibility that a single technological device could bring about a worldwide revolution? The newly launched James Webb Space Telescope has already attained the position of a famous space telescope in the eyes of the scientific community. In spite of this, the telescope is nothing more than a technological marvel that humanity has constructed in order to finally comprehend the universe. It was the result of decades of labor that was both meticulous and imaginative. We are aware that the $11 billion that were spent on the construction of this record-breaking telescope was more than justified. The telescope has been fully operational since the summer of 2022, and the images that it has taken thus far are demonstrating that we were completely incorrect about everything. The Big Bang is now being investigated by scientists. It's highly likely that our assumptions about how the universe and galaxies came into existence were utterly wrong. It is necessary to reevaluate the age of the universe as well as its limitlessness or infiniteness from the ground up. The galaxies that were discovered by Webb are so old and perfect that they cannot be explained by a universe that is yet relatively young. There were photographs taken from the beginning of time that showed black holes that, according to our antiquated understanding of astrophysics, could not have existed due to the tremendous magnitude of these objects. At this point in time, we need to be receptive to novel concepts and perspectives on the world. Even before the year 2007, planets similar to it served as a warning to the scientific community when they were discovered. In light of the launch of the Webb Space Telescope, we have been forced to acknowledge that our understanding of the cosmos is restricted and that we still have a significant distance to travel. Due to its remarkable technological capabilities, the James Webb Space Telescope is the most advanced telescope that has ever been built. With its enormous 6.5-meter main mirror and cutting-edge infrared equipment, the Webb Space Telescope is able to gain a glimpse into the most remote and inaccessible regions of the universe. Because of its remarkable sensitivity, it is able to accurately identify light sources that are 13.5 billion years old, which is the same age as the universe itself. It is possible for Webb to see through dense nebulae, which other telescopes are unable to do. As a result, it is able to reveal planets and stars that were previously hidden from view. Due to the fact that it is able to explore the universe with an unrivaled level of precision, the James Webb Telescope is an invaluable asset to the field of astronomy. Every day, fresh discoveries about the universe are being made publicly available. When it comes to Webb, what will 2007 OR10 reveal? Imagine that the James Webb Space Telescope, jwst, pointed its precise sensors in the direction of the mysterious minor planet 2007 OR10. With the help of Webb's advanced infrared sensors and spectroscopy instruments, it may be possible to investigate the surface composition of this distant celestial body in a level of depth that has never been seen before. The mid-infrared instrument and the near-infrared spectrograph that Webb has could be utilized in order to ascertain the precise chemical makeup of the components that were utilized for the 2007 OR10 mission. Taking a photograph with a spectrometer could provide us with some fascinating insights into the narrative that these intricate chemical components are trying to inform us about. According to the findings of the researchers, the distinctive color of the planet is due to the residues of these compounds, which become apparent when ultraviolet light reacts with methane and other simple organic molecules. As a result of the fact that they are the fundamental components of more intricate organic compounds, astrobiologists believe them to be particularly fascinating due to the potential role that they could play in the beginning of life. It has already been found that these kinds of compounds are present in close proximity to a number of the moons that orbit the solar system. These moons are also excellent contenders for the earliest evidence of life beyond Earth. The fact that they are found on planetary bodies such as 2007 OR10 provides evidence that moons and dwarf planets may have played an unanticipated role in the process of the genesis of life in the solar system. We get important insights into the physical and chemical conditions that existed in the early stages of the solar system, and these compounds may provide us with information regarding the development and transformation of organic matter in the outer regions of the solar system. The most essential thing that Webb could do for the geology and environment of our dwarf planet is to confirm the existence of water ice and other frozen elements. In addition to these astounding indicators of life, there is yet another mystery regarding the existence of the year 2007 OR10. Due to the fact that the planet's orbit has not been completely verified, it is currently listed with a catalog number that is considered to be provisional, and it does not include a recognized name. There is still a lot of ambiguity around its precise orbit and the physical properties it possesses. Because of its immense distance from Earth, 2007 OR10 could only be observed under extremely difficult conditions with earlier telescopes. This was the only way to observe it. This is where Webb has the potential to be an extremely significant asset. Long-term monitoring and precise observations collected by the telescope could be used to accurately determine the spin period of the planet and track its orbital movements in the Kuiper belt. Both of these goals could be accomplished. It is necessary to have this data in order to accurately calculate the orbit of the planet, and after all of the standards that have been established by the International Astronomical Union have been completed, the planet will be formally named. It is Webb's mission to investigate the mysterious renegade planets. Planets that deviate from their normal course are not a novel phenomenon, are they? These celestial bodies, which are planets in orbit around the Sun and present difficult study hurdles, are similar to the one that was discovered in 2007 OR10. However, despite the fact that they are only specks in the vastness of interplanetary space, planets are still material entities. One who is sensible would not have had any doubts about this. There are times when scientists are able to identify one of these planets, but as soon as they do so, they disappear into the cosmos, making it impossible for them to be observed again. These elusive planets are not beyond the capability of the James Webb Telescope to identify and investigate when they are discovered. The sophisticated infrared detectors on the Webb Space Telescope are able to detect even the faint thermal intrinsic radiation of rogue planets. Despite the fact that they orbit around stars that emit light, these planetary bodies do not possess their own sources of light. However, even these planets release a little amount of radiation due to the processes that occur within them and the motion that they experience as they travel through space. This motion can be detected by sophisticated technology such as that which is used by Webb. Planetary scientists will finally be able to investigate the composition and properties of planets in free orbit, which will give light on how these planets form. This astonishing development will allow them to research the planets in free orbit. There is a possibility that with Webb's assistance, we will have a better understanding of the distribution and abundance of rogue planets in our galaxy. The findings of the researchers indicate that these occurrences appear to adhere to a standard pattern. The frequency of this event, as well as the region of the world in which it takes place, is something that we need to know in order to advance our understanding of the universe. Through its precise analyses, Webb was able to uncover the fundamental structure as well as the potential geological activity of even the smallest thermal emissions from the year 2007, known as OR10. Planets that wander while displaying traces of geologic processes and active centers provide yet another example of a scientific marvel. Since the beginning of our investigations, the universe has reminded us on multiple occasions that the word impossible is devoid of any significance. Neptunes, magnificent and blazingly hot. The ice giant Neptune, which has a way that is a deep blue and a temperature that is relatively cold, is located close to the outermost part of the solar system. With that being said, are you familiar with the concept of really hot Neptunes? It has been discovered that yet another remarkable new category of extrasolar planets has been located, and we would not have been able to find them if it were not for the significant advancements in observational technology. In spite of the fact that these planets circle their stars at tremendous distances, they are frequently much closer to our Sun than Mercury is. Their composition is equivalent to that of Neptune. Because of their proximity to one another, the surfaces of these planets, which are similar to Neptune, are experiencing extraordinarily high temperatures. Having temperatures that are higher than 1700 degrees Celsius, these planets can be terrifying things. Furthermore, these extreme conditions not only produce a multitude of other amazing occurrences, but they also completely invalidate the existing idea of how planets develop and evolve. Because of their highly hot surface, Neptunes that are exceedingly hot have the ability to break down gases like as methane, hydrogen, and helium into the atoms that make up their constituent parts. It is possible for such incredibly high temperatures to result in atmospheric escape, which is the process by which planets shed gaseous components as a result of tremendous star winds and severe radiation hitting them. One of the Neptunes that is particularly noteworthy for its exceptionally high temperatures is Celt 9b. This particular Neptune is so hot that it causes water and other molecules that are stable to break down into hydrogen atoms. Our conventional theories of planet formation predict that extremely hot Neptunes should not exist, hence the fact that they do exist questions the assumptions that we have had for a very long time. They would have to be destroyed by either their development or the tremendous light from the stars in order for them to be destroyed. As a consequence of their findings, scientists are compelled to develop new perspectives and concepts, which poses a challenge to the understanding that we already possess. An opportunity that comes along only once in a lifetime to gain knowledge about the processes of planetary migration and atmospheric escape is afforded by the extreme conditions that exist on these worlds. In recent times, the James Webb Telescope has turned its attention to the exploration of extremely hot Neptunes, which has become an area of essential relevance. Through the use of Webb's cutting-edge infrared technology, it is also possible to conduct in-depth research on the thermal radiation and spectral properties of these planets. It is possible for Webb to conduct an analysis of the composition of the atmosphere in order to determine whether or not molecules are present on extremely hot Neptunes. We require these data in order to have an understanding of the chemical reactions that take place under specific conditions. Through the use of infrared spectroscopy, Webb is able to easily examine the atmospheres of these planets and identify the distinctive chemical signatures that they possess. Exploration of intense stellar radiation is possible, as is the creation of maps depicting the distribution of elements and molecules. Through its long-form observations, the Webb Space Telescope is able to gain a deeper understanding of the mechanisms that are involved in the migration of planets and to maintain a careful eye on the atmospheric losses that occur on these planets. As additional information regarding the rate and amount of air loss becomes available, it will be possible to have a clearer understanding of how these planets came to be so close to their stars and what processes keep them there. We get a deeper understanding of the intricate relationship between the physical and chemical processes that occur throughout the cosmos, which leads to improvements in the models that describe the formation and evolution of planets. Researchers have been harboring the idea that the cosmos may be home to other forces that have not yet been identified, and that these forces may hold the key to solving the mystery ever since the launch of the Webb Space Telescope. We have the most powerful secret weapon in the jwst to unravel these mysteries, and every strange and unexplained discovery leads to these forces as the source of their existence. A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.